Alright, so we're going to go over some theorems about similarity here. These are going to be theorems that will show us that two triangles are similar. So far we started out with assuming that the two triangles are similar. Now we're going to figure out how to prove that they're similar. So, first just to review, so triangles are similar if and only if their corresponding angles are congruent and their corresponding sides are proportional. So, when we know that two triangles are similar, we know that all the angles are congruent, corresponding angles. And we know that that whole proportion statement holds, right? The corresponding sides are all in the same proportion. Turns out, though, there's some shortcuts, and this is what the theorems are. The shortcuts tell us, these theorems tell us how to prove that two triangles are similar, even if we don't have quite all that information. The first theorem that we're going to talk about, and I've sort of used this already, but is called angle, angle, angle. So, if I know, for instance, I've got two triangles here, ABC and DEF. If I know that, say, this is 50 degrees and this is 45 degrees and this is 85 degrees, and then I know that this is also 50 degrees, 45 degrees, and 85 degrees. Okay, then I know that, angle A is congruent to angle D. They're both 50. I know that angle C is congruent to angle F. So they're both 45. I know angle B is congruent to angle E. They're both 85. The angle, angle, angle theorem tells me that if the corresponding angles of the two triangles are congruent, then the triangles are similar. So I know that 50 and 50, 45, 45, 85, 85. I know the angles are congruent, the corresponding angles are congruent, so I can conclude that therefore, triangle ABC is similar to triangle DEF. And again, I'm always making sure that the order in the second triangle corresponds to the order in the first triangle. So this is my conclusion. I get that by angle, angle, angle similarity. Now, some of you might be thinking, oh wait, do I really need to know all that, right? Because, well, what? If I know, let's go back to this example. Suppose I only knew that this was 50 degrees and D was 50 degrees, and I knew that C was 45 degrees and F was 45 degrees. Well, I've got two angles, right? A is congruent to D, angle D, just like before, and angle C congruent to angle F, just like before. Well, if I know that, then I know that the sum of the angles in a triangle has to be 180, right? We've done that plenty of times. So we know that 50, 45, that this is going to have to be 85, and 50 and 45, this is going to have to be 85 as well. So if I know two of the angles the corresponding angles are congruent, then I know that the third one's going to be congruent as well. So I kind of get that B and E for free. So that really tells me that I only need to know that if two pairs of corresponding angles in two triangles are congruent, then the triangles are similar. And that's called angle-angle similarity. It's essentially the same thing as angle-angle-angle, but we just realize we can take there's an even shorter shortcut, which is just if you've got two congruent pairs, two pairs of angles that are congruent in two triangles, then you know that they're similar. So from just this information, A is congruent to D, C is congruent to F, I can say, therefore, triangle ABC is similar to triangle DEF. And just to note, it doesn't really matter if I know the measures of the triangles, right? If I had A, B, C, D, E, F. As long as I know that they're congruent, so if I know A is congruent to D, right, they both have the one hash mark, so that means that A and D are the same measure. And I know that, say, C and F are congruent, right, because they both have the two hash marks. It doesn't matter that I don't know that what the measures of these angles are. Whatever they are, B and E are going to have to be the same as well, because B is going to be 180 minus the sum of these two. E is going to be 180 minus the sum of these two. But since A and C, A plus C, D plus F are going to be the same, I know that B and E will also be congruent. So, again, angle-angle similarity tells me if two pairs of corresponding angles in two triangles are congruent, then the triangles are similar. All right. Third theorem on the back of that page is called side-side-side similarity. This tells me if the corresponding sides in two triangles are proportional, then the triangles are similar. So, here's our two triangles, ABC, DEF. Oh, the D got cut off there. Sorry, put that in. The question is triangle ABC similar to DEF? What we want to know is if the ratios are all the same. If that proportion statement is true. AB over DE equals BC over EF equals AC over DF. Well, what we'll do to figure that out is just write in what we know. Okay, AB and DE. So that's AB is 6, all right? DE is 9, BC is 5, EF is 7.5. And AC is 10, and DF is 15. Okay, go and try. Now, are they all are these all the same? Well, the easiest way to figure out if fractions are equal is to just divide. So go to your calculator and do 6 divided by 9. 6 divided by 9, and you get 0.667. 6 repeating. Go back and do 5 divided by 7.5. Oh, you get the same thing. So these two are the same. And then the last one is 10 divided by 15. And that's also 0.6667. So, all these ratios are equal. They all equal 0.667. What they really are is all 2/3. These are the same, equal. So this statement is true. Sorry, scratch that, but you know what I mean. Okay, so therefore, by side-side-side similarity, since the corresponding sides are proportional, I could say, therefore, triangle ABC is similar to triangle DEF. Done. I would say that's by side-side-side. Do I use the side-side-side theorem? Right? Okay. Last one is called side-angle-side. This one says if two pairs of corresponding sides are proportional, so not all three, but just two pairs. If two pairs of corresponding sides are proportional and their included angles are congruent, then the two triangles are similar. Now, this is going to be important. What do we mean? In order to use this theorem, we need to first show that two pairs of sides are proportional. Well, we're trying to find, the question is, is triangle ABC similar to triangle DEF? Well, let's look at the proportions again. Just like we did with side-side-side, we're going to look at the proportions. AB goes with ED, and that's 4 over 8. BC goes with EF, that's BC is 3, EF is 6. Now, however you want to do this, 4/8 is the same as 1/2. 3/6 is the same as 1/2. If you want to do it in your calculator, fine. 4 divided by 8 is 0.5. 3 divided by 6 is 0.5. Point is that these two are equal. Okay, so the ratio between this side and this side is the same as the ratio between this side here and this side here. We want to now the side-angle-side theorem says if two pairs of corresponding sides are proportional, check, and their included angles are congruent. Now, the included angle means the angle in between the two sides we use. The included angle is the angle between the two sides we're using. So we used AB and BC in this triangle, so the angle between them is angle B. In this triangle, we use DE and EF. The angle between them, the included angle, is angle E. Well, we know angle B is 87 degrees. Angle E is 87 degrees. We've got that on the diagram. So these are equal. So, the included angles are congruent. The corresponding sides are proportional. So we can say, therefore, triangle ABC is similar to triangle DEF by SAS